Okay, my dear students, we have to start the new lesson that in second year syllabus. That is what most important for objective point of view. Okay, so that is current electricity. This is the second year topic. Current electricity. Current electricity were board exams of national wide board exams and objective point of view national wide exams also. This is the most important topic. Current electricity. Everybody should listen carefully and write the important points, okay, which I will have to discuss in our class, okay. Don't neglect, don't lose your concentration. Let me start the class now. Yes? Are you ready to listen? Yes, sir. Let me have to discuss, let me have to start the new lesson, that is the current electricity, the most important chapter. Current electricity. Okay, current electricity. In electricity we have electric charges and fields is there, electrostatic potential and capacitance is there. Those two chapters we have to call the electrostatics. What is electrostatics? Electrostatics. What is electrostatics? Study the charges at rest. Study the charges at rest. Study the charges at rest. A rest charge which is produces only electric field. Around that charge, we can discuss the force experienced in different positions and related topics we have to discuss. Potential and intensity of electric field, Coulomb's inverse curve, all those are also we have to discuss in those chapters. So here what is electrostatics? Study the charges at rest. Then what about this current electricity? Current electricity, what about this present chapter named current electricity is what? Study the charges in motion. Study current electricity. Current electricity. Study the charge is in motion. Okay. Study the charge is in motion. Generally, we have to observe that we have to use the current status and current affair. Current is nothing but the present, that active. So here charge is motion, the charge is always active. So we can discuss the moving charge is, what about the moving charge which is related to other concepts? We have to discuss that in current electricity. So here in the chapter, first topic we have to discuss. What is that first topic? Electric current. We have to discuss that electric current. What is the statement of the electric current? What are the SI units of electric current? Then how to define that units based on that statement. Okay? Electric current. This is the first statement. Denoted small I or capital I. Small I or capital I. So this is the conductor now. The charge is passing through the conductor. The charge is passing through the conductor. Across the conductor. Charge flows across the conductor. So that's why charge is flowing through the conductor per unit. That is the statement of electric current. I repeat once. Charge flowing through the conductor per unit time. So this is the charge which is flowing through the conductor per unit time. This is the conductor. Q is the charge. and t is the time, then I is equals to q by t. This is, we can take the average current. Average current. Here I is constant. Average current I is equals to q by t. Then this we can write like this also, I is equals to delta q by delta t also. Average current. Okay. Then what is the instantaneous current? Current at a particular instant of time. So how to write the instantaneous current? I instantaneous that is equals to limit delta t tends to 0, delta q by delta t. This we can write dq by dt. So then the instantaneous current I is equals to differential form with respect to time. This is the instantaneous current I is equals to dq by dt. Okay, how to discuss the statement of the current and average current expression and instantaneous current expression also. Then what is the SI unit of the current? SI unit. What is the SI unit? Ampere. Ampere. What is the statement of the ampere? 1 ampere is equals to 1 C by 1 second. One ampere is equals to 1 C by 1 second. Based on this, we can define the statement of the ampere. How to define the statement of the ampere? Very easy, you know that. 1 coulomb charge is flowing through the conductor per 1 second. 1 coulomb charge is flowing through the conductor per 1 second. So that is what? 1 ampere. 1 coulomb charge passing through the conductor per 1 second, which is equals to 1 ampere. Okay, this is the current related topics are there. Few more current related topics are there we have. Okay, how to discuss after this board. Okay, yes. Okay. Now we can discuss the few more concepts in electric current. Okay. So here I is constant. How to calculate the charge? If current I is constant, we can calculate the charge directly like this. I constant. How to calculate the charge? Directly we can multiply with current and time. Okay. So that I is equals to q by t. Then q is equals to I into t. So we can calculate the charge like this as it is. Okay now? But it is possible the current is constant only. Then if the current which is varies with respect to time, how to calculate the charge? Okay, that's why then we can integrate it, we can calculate the charge, we can use the mathematical concept integration to calculate the charge. Okay now? Then if I is varies with respect to time t, how to calculate the charge? That we can take the instantaneous current expression I is equals to dq by dt, then dq is equals to I dt. We can calculate the charge within the limits, within the particular points. So, with the limits T1 and T2. So by integration of dq is equals to integration of I dt with the time limits T1 and T2. So this is the principle, my dear students. If the current which is varies, how to calculate the charge, that is Q is equals to integration T1 to T2 I dt. Okay? This is the principle. You understand now? Then you don't understand, again I will explain you. I think you understand. This is the very easy concept now. You understand very well. Okay? So then we can calculate the charge like this within these two time intervals. Next, we can discuss few more concepts about the current. In our lower standard, just we have to define the statement of the current and write the principle of the current. But here in this 11th and 12th class, the current related topics are more. Why? Because here objective concepts are there. So that's why we can discuss all those objective concepts also. So like this, all these are to give the proper information about the current. Okay? Next. I is a scalar or vector, that is one of the questions, my dear students. That is most important to ask the conceptual bit also, in mains and NEET also. I. Electric current which is having the direction and also it is having the magnitude. It is having direction and also having the magnitude. But it is scalar or vector? Compulsory electric current is scalar. It is scalar. Why? Because it having the magnitude and direction also, but does not obey the law of vector addition. Not obey the law of vector addition. Okay, now? Not obey the law of vector addition. That's why electric current we have to take, or we have to treat a scalar. Okay? Then two more concepts are there related to the electric current. Then electric current is the fundamental physical quantity or derived physical quantity. Do you know? Electrical current is the fundamental physical quantity or derived physical quantity. How many fundamental physical quantities are there we have? Do you know? You don't know. But we have 7 fundamental physical quantities are there. That is the first year topic in units and measurements. How to discuss all those concepts? We have 7 fundamental physical quantities are there, 2 supplementary physical quantities are there. Those are mass, length, time, electric current, thermodynamic temperature, luminous intensity and quantity of the substance. These are the 7. The next 2 supplementary physical quantities, plane angle, solid angle. Total 9. are the fundamental physical quantities, and electric current is also one of the fundamental physical quantities. It is independent of any other. Okay. Now, if electric current is nothing but flow of the electrons, so electric current is always opposite to the direction of the motion of the electrons, you know. That is, you know very well, I think. Electrons are moving from left to right, current is flowing from right to left, opposite to the direction of the electrons. Okay? So that's why, if the electron which is moving in the circular path with respect to an axis, if an electron revolving or moving in a circular path with respect to the center or with respect to an axis, how much the current is flowing due to that electron? We want the current expression in terms of frequency, angular frequency, and in terms of frequency, and in terms of velocity, linear velocity. We have to derive now all those principles now. Are you ready? Yes, we can discuss it. Yes, if an electron moving in a circular path of radius r with uniform angular velocity omega. With uniform angular velocity omega, with uniform angular velocity omega. Okay? The diagram. Everybody look at the board. Okay? Don't nervous. The very easy concept now. Electron moving like this. The electron is moving like this in a circular path and its radius is r with angular velocity omega. And the electron linear velocity is always along the tangential v. Okay? This is the center. So we know that V is equals to R omega. Then current I is equals to Q by T. It will be right Q by F also. F is equals to 1 by T. Reciprocal of the time, that is frequency. So I is equals to QF. But omega is equals to 2 phi F. F is equals to omega by 2 phi now. Substitute here. I is equals to Q. F is nothing but omega by 2 phi. So I is equals to QF, but F is equals to omega by 2. I is equals to Q omega by 2 phi. And also, we know that V is equals to R omega na. Omega is equals to what? V by R. Here we have to substitute the current expression I is equals to Q V by 2 phi R. So this is the current expression, my dear students. So here few more current expressions are there. This is the current expression in terms of frequency. This is the current expression in terms of frequency, and this is the current expression in terms of angular velocity, and this is the current expression in terms of linear velocity. V is what? Velocity. So this is another concept of current, my dear students. Okay. So, this is a very basic introduction concept in current electricity. Just have to start at the current electricity concept. Current electricity chapter, that is a huge chapter now, and most important for objective for NEET and JEE means also 3-4 questions. In JEE means 2 questions compulsory in this, and NEET 2 to 3 questions, 3 questions in this current electricity. Okay, the most important concept, electric current concept is completed. Okay, electric current concept is completed. Total electric current concept is completed. Okay, then based on this electric current, we have to solve few model problems also. Based on this only current concept, based on the current concept, we have to solve 3-4 model problems in our next session. Okay. So every session I told you that always in each and every session I told you that, dear students, don't lose your concentration and improve the problem solving strategy, skills, problem solving skills you have to improve. The next, revise all the concepts and solve the numerical problems for some topic was not total chapter. So today we have to discuss that electric current. Electric current is a small topic. Then we have to discuss all the concepts related to this small topic. You have to solve few numericals. Either it is 2, 3, 4, whatever it, different models. That is most helpful to getting the good score in exams, national-wide competitive exams, objective exams. Okay. Let me continue the related topics. Let me continue the related continuation topics in our next session. Okay. Thank you.